Everyone, I'm all to the Dassault Systems SolidWorks simulation webinar. Talking about myths of CFD in this webinar today, and we also address how incorrect these myths are. Today are apprehensive of using CFD tools because of the myths associated with them. The myths are too difficult to use, data consuming, needs to be recreated, must not need CFD analysis, and more. Today, let you know how incorrect these myths are and how we can implement the present generation of powerful CFD tools like SolidWorks Flow Simulation in your process to do better and faster product development. We will do a session at the end of this webinar today. So if you have questions, please type in the Q&A or the chat window for us to address them. And have a poll question at the end of this webinar today. With this, I would like to introduce the host of today's webinar, Mr. Kapil Gaitonde. He is the Technical Manager, Simulation Products, South and India. He has rich experience of 15 years in the field of design analysis. Kapil is an expert in FEA, CFD, and helped many designers to implement simulation products in their cycle effectively. With this, on this session today to Kapil. Kapil, over to you.
Thank you. Waiting for the controls.
The host now?
Yeah, I'm the host. I'm not yet able to share the desktop. Okay, controls. No problem. One instantly, but a quick input, the poll window or the chat window that you can hear us would be great. Your confirmation that you all can hear me clearly, and if it all looks good. Can I get input from the chat window that you can hear? Yes, looks good. The code should be good for me. I think excellent. Thanks a lot. I'll not take too much. As I mentioned, today's webcast is on myths of CFD, and she has already given an introduction to me. My name is Kapil Gaitonde. I'm the Technical Manager for Simulation Products, based in Singapore, and I'm covering the South Asian countries, India, and New Zealand, specifically for simulation products. Let's start. Myths. We hear a lot about it, and thankfully we are scared of searching CFDs because of them. There are, I have listed down a few of them. Those could be CFD is difficult to use and implement in the design process. This is one of the most common things, and it is like just a thought, especially those who have learned it either in their education or from experts who are using CFD tools. Typically, they give big pictures, complex pictures, and we are scared. I would say you are scared of touching the software. It usually ends up saying it's not our cup of tea. Of course, as a design manager or one involved in the design process, we will be always worried that they might increase this design process, and it might take more time designing a certain product. Another part of it, in terms of CAD models, those who have already tried it or you have seen it, see, when we move the CAD models from it could be CAD tool to a analysis software or a CFD software, we are worried, and it does happen that a huge amount of data loss takes place, and that the things will actually increase the design process, and we want to do it. Movement is expensive. In fact, most of the CFD tools in the market are quite expensive. But definitely, we mentioned today the tools that are available in the present generation, like the one that you will be seeing today, SolidWorks flow simulation, should fair enough on the results, on the quality or on the delivery that it is going to do, compare cost that one might want to invest into it. It's a kind of interesting thing wherein we assume that most of the products that we design may not need the analysis. Of course, of the presentation, on a quick note, I'd like to go through a few different applications. You have to correlate yourself with the available applications that we have, and if at all your products are present in that. Yes, there is a common understanding that no, we don't need the analysis. It needs a huge amount of expertise. Yes, the complex tools, lot of technical knowledge on CFD as well as an application-oriented knowledge is required. And yes, we might take a back step considering the fact that it is an expert tool. But how much these myths are true and are they really affecting? Is there a tool which can make life easier? Let's look on how the changes are coming into the present generation of tools. This was the past scenario wherein design was typically done in a CAD software, and it could be a separate team which did the entire designing. It was quite complex. And thereon, there would be one more team where the analysis was given for, and typically the level goals were known, and there was a kind of wall between these two teams. These teams worked independently, and there was no much interaction between them. Obviously, the team of specialists were considered to be specialists, and they didn't interact too much with the CAD and the present. This is also leading to, as we discussed before, import of the CAD part. A bit of misunderstanding on what a design wants. There is a potential of this thing happening, wherein a designer wants something and not be conveyed to the list. So these remain. So you will see the presentation of tools. You find that gap no more exists. These things, that is the analysis part and the design or the CAD part of it, can concurrent or parallel together at the same time. So it's completely different processes, and you will definitely be able to do it at the same time. No more import and export. It all looks integrated into a single front end. A bit more into it, what it is exactly about. And if we talk about our software called flow simulation, we discuss on these different technologies which are specifically imbibed in the software. We address all these common problems or attentions because of which the tools are not used. One of you saw very well or discussed that was mentioned a few seconds back. It will be concurrent to the CAD or the designing part of it. So it is not a process, it is not happening separately. And once, because it is well embedded into the CAD platform, in case we have SolidWorks over here. Typically, boundary conditions and mapping especially, it's a very complex task if it has to be done manually. There are companies and experts who dedicated people for doing only this task. However, our solution, you'll see that it is well integrated and it happens automatically. Most of the things are taken care automatically. And, it is that users don't have control, they do have control. However, that helps them a lot in doing the meshing part of it. One discussion items in flow is turbulence modeling. Typically, users are worried on which turbulence model to be used, whether to use the turbulence model or not, whether the right turbulence model is used, etc. In software, you will find that all these things are done automatically. Software consideration the flow conditions on whether to use a turbulent model or a linear model. This happens automatically. Next, one more interesting phenomenon. I'll show you once I go into that slide more detail. Again, this happens automatically. We need not worry on where the modulators could be coming, how much capture, whether they are captured properly, polished and care by the software. Once we want to ensure that the convergence will happen, and typically it is a difficult task. However, from our software point of view, it is done first of all automatically. There are goals which can be set as engineer's requirement and not as per the analyst thought, and we can get what we want from the software. For iterations, we also want to, we don't end up with doing one iteration, we want to do many iterations. We want to understand what if I do certain changes, what is the response of the model. And yes, again, that is a very handy tool. The easier it is in the software, the better it will be. Finally, it is definitely huge because of all this integration with the comfort level that is seen in the CAD front end and the model. If you, especially in case of SolidWorks, if you comfort with SolidWorks, there is nothing big or new or different you need to learn. It is all seamless and intuitive. Especially it is intuitive. You don't need an expert to teach you. You can learn the front end easily. The knowledge that is required is the domain knowledge, which I believe you all already have it. But to just implement it in this software. See a bit more into it. What I meant by embedded within SolidWorks, as you directly using the SolidWorks CAD geometry. So no more import and export. Again, in most of the software, we spend a lot of time detecting the fluid region, creating the fluid region. The CAD has to be privated. However, in this case, we need not. It is done by the software on a case. No, I told you about this CAD integration, design changes. So typically, it is not only, as I'm discussing Concurrent, I think it is not only about analysis of a single part, but I am going to change the design. All these changes should be easily implemented in the software. If not, it is a problem. Benefits, yes, translation. So no need of a neutral format by which we are going to translate. We are getting the entire geometry as it is without any data loss. Obviously, it is parametric, so any just can be done parametrically, and you can talk to each other. That is analysis and CAD. This is the way it works. It is happening automatically. No extra tools required to search for regions, creating them and using them. Find more towards if different and if it is implemented, definitely it is going to reduce the design cycle. Yes, at a stage you might appear an expert is there. Definitely it's for good. The design would be of a better quality. I told you the meshing part of it, especially if you see the bottom image here. This particular complex mesh is not created by the user but by the software. So software is intelligent tools by which it can understand where it needs quality mesh, and it will automatically improve the quality of the mesh at those locations, and it will coarsen the mesh at other locations. So the manual meshing time is more required. People end up doing a lot of work and understanding how could the flow be and where I need a better mesh. However, our tool, it can happen automatically. Sometimes we don't have too many controls on the mesh, we don't have too many elements, but that's a fact. Even if we have many elements, if the user who is going to use it, each of expertise is required for that. However, the available quality and quantity of elements and the intelligent meshing techniques that we have, it suffices to all the requirements of a user and give the result for the expectation. It is not one iteration. I want to do multiple iterations. So there are options in the software. As this entire model is completely linked to the CAD geometry, you can do any changes into the CAD geometry, and those can be tested directly in the virtual front end without too much iterations or interaction from the user. He just specify the software on the iterations that he has to do, and can do it for us. Now, result accuracy. Now, like what we say, FEA or structural analysis result, but it not be a converged result or accurate result. And one of the biggest tasks for a SFD analyst will be ensuring that results are actually the converged results. that there are different techniques that one might use. But in our case, we have it from something called as engineering goals. So, again, example, if I'm designing a motor, for me, one of the most important engineering goal will be the outlet head, the head created at the outlet. So, I can actually tell the software on the important result that you want to look at, and this will ensure that that particular goal converges to the extent that you specified to you. So, user need not worry of two different things, and this has different kinds of options which are typically easy to use, easy to understand, and implement. So that should help you to do a particular CFD analysis and get good converge results or accurate converge results. I told you this is in itself it is quite complex, and I'm sure that all is detected and implemented well. So if that happens, either the user needs the expertise to do that, or we have to use our terminal model, or we end up using something which is incorrect. It is also difficult to understand on where or which turbulence model to be used. In our case, as I told you, it is automatic. For some, we can force the software to solve it with laminar or turbulent conditions. If we leave it for the software to decide, then it can understand based on the turbulence that is created, the Reynolds number, based on the velocities or the same velocities, to decide whether a turbulence is occurring and it has to be used. We will use K epsilon model, and it's definitely not taxing anything on the user. User will not worry about this particular topic. And one of the interesting parts, especially for thin structures, walls on huge velocity changes, are interested in understanding the boundary layer, how it happens, what is the velocity drop, how quickly is the boundary layer. And one of the challenges for a CFD analyst is to ensure that the boundary layer is captured properly. Again, it could be done if that is not there. We have to ensure that the mesh is appropriate at that location. The grain of the mesh is good, and that's the only way we can ensure that the mesh looks perfect. However, in our software, the maximum or the worst thing that you need to give software is the length of the boundary, and the software will ensure that the captured correctly across that particular boundary layer, and that's it. Again, another huge difference, and that should help you capture layers effectively. Definitely, this will help you in having accurate simulations, the wall trace, and one of the important things that one might need. Definitely, it is easy to use, intuitive spelling, and especially the SolidWorks users who are already using SolidWorks, the thing that you need to learn, it is the same front end. Only extra features or buttons would come up into picture, and if comfortable with your domain, you can start using it as early as possible. The learning curve for this software is easy, small rather, and it can be implemented and used fast and effectively. The different, initially I showed you these different technologies, and I also highlighted a bit on how they are, what exactly they are. So in the available short time, I had tried to cover them. As I mentioned, it would also, one of the biggest myths is, do I really need it? So highlight on a few different applications. It could be simple press drop which we want to see. And one of the common things which I mentioned is, like any other thing, unfortunately, in case of flow, if gas or liquid, we cannot visualize what exactly is happening into the fluid. It is only black box. Behind conditions, we know some values at some end, however, we do not know the entire phenomena. And only software can help you understand that. So if it is like all or any controlling hydraulic control, typically that we need is something called as coefficients like CV, KV, Q, etc. So you can understand them from the software. It could have things like pumps where you want to ensure the pump efficiency, you want to design a fan curve, etc. So those could be the few simple applications. The pressure drop could be temperature. heat transfer. So examples could be um, electrics, it could be pressure vessels, it could be towers, or brake lining, oil cooler. So over here, we also want to understand interaction happens between the fluid, liquids, gases, and the solid entity. How efficiently the heat is being transmitted. There, in such cases, we need a software like Flow to understand the interaction between these two. And understanding could be towards forces or the flow fields that are coming into picture. As it is really difficult to visualize on what is happening for the fluid. In this particular example over here, you can see there is kind of recirculation that is happening and it can be visualized only from there. So yes, there are practical tests that are done for visualizing such things, but it is expensive and not that 100% easy to understand or visualize. It could be other smaller recirculations, etc., happening in things like this, or pumps wherein it is really complex to know what is happening exactly internally. If you understand those things, you can get rid of problems like cavitation. If there be places where huge amount of negative pressure could be coming, you can stand and do that. Other mixing processes, either in chemical industry or it could be in taps like this. It could be mixing of hot and cold water. It could be mixing of gases. You understand how the thing happens, how much percentage of what can be a certain output. So mixing processes can be understood and implemented. Another completely different domain wherein you want to understand what fluid or gases are present around it. So when they move, what is the kind of impact or what is the kind of force or pressure they bring on the actual entity, and that's what you can understand. Actions could be aerodynamics. It is simple. You can understand the pressure inside it, and other end of derived output could be torque conditions. You want to understand the torque that is created when such a force comes on a rotating wall or a wall that is being rotated. So, things wherein the pressure of structural forces or pressure need to be understood, we can understand. And it not end over here. I'm not discussing it today, but if at all we have simulation, we can take these forces and pressures to simulation and get understanding on what could be the impact of those forces and pressures. I believe I'm on time and time for questions. I'll open it up. But for that, I would like to have a quick call which Kavita is executing, and I would like to have your input. In the chat window is open. Feel free to ask any questions. This is all for today from my end. Eyeball is already triggered. Please feel free to your input. That is already used to us. In the WebEx tool, you might see two different things. One is called as the chat window, other one is the questions window. Please use the chat window only to ask me questions because that is the one that I am monitoring at the moment. Please use that window to ask. Who wants to check if I'm going to show a demo today? Unfortunately, no. Today it was not in plan. However, in terms of understanding of the software, anything, please ask. Then definitely you can request. Either you can drop me email or you can in the call. Definitely one of our executives will approach you for to deliver demo. Okay, I can see good questions. See a few questions which are specific, especially those who are already using the flow simulation, I guess. I would suggest, because it is difficult to use this forum to clarify what is happening and help you out. Either drop me an email or you can always contact our partner if you're you're connected to one of our technical support guys over there. One of the basic things which I forgot, and I think I can do it even now. Email address. I'll put it down here. Please approach me, and I'll so that you get the right help. Let me just okay. Puts on cavitation. Good point. If I were from software point of view, what we are giving or what we say is only negative pressure, and negative pressures are coming. A huge amount of calculation happens, which is normal calculation. So from the software point of view, we are not complicating the things. We are just permitting the user to select a particular checkbox, and that is going to help doing the or it is telling the software to do those extra calculations. Software pop up warning telling that yes, cavitation is happening, attention is required. And on different pressure variations, especially where negative pressure is there, we improve the quality of number one, the mesh, and help the solver to do some calculation. By iterate, the polling window is open. Use it to give your feedback. That is the only way we can help you out in future. Of course, mail is there. Okay, there is mixture, but let me see. I think I have missed out on a few more questions. Okay, which says what noise level optimization. Now, again, these pressure values or pressure distributions can lead to noise variations, and that like there are specialized software which do noise prediction, etc., or decibel level. In our software, from pressure variation or pressure distribution, we understand we can understand and the equations or small calculations which can help us convert these distributions to noise levels, and that's done, and that's the way we help optimizing noise levels. Question on the accuracy, definitely that's one of the primary things in a mathematical tool. So definitely it is not one of the question, like apart from water and air, is it in other domains also? Answer yes. To be more specific, the differentiation is made between Newtonian and non-Newtonian fluids. So Newtonian, definitely all the fluids can be handled accurately. Note on that. We provide a verification manual with a set of examples which are not only compared to practical conditions but also to theoretical calculations, and that tells how accurate or how matching the software is. Then which says how efficient is what is in here. So put it in this way, it is directly proportional. Because it is parametric, because it is within SolidWorks CAD, it is directly linked. So definitely efficiency in terms of handling it is very good. You have direct control on the parametric model. The effect of it in terms of efficiency could be in terms of solution. So obviously, the parameters, the more the solution time, and that's the way it is. And there is no shortcut for that. It depends on the hardware capability, and it should be quite fast. So the questions. Okay. Can forces extracted through C analysis be used to know the response of the structure as been FEA? Answer, as I told you, typically the structural analysis, it could be pressure and forces on walls or structures which you want to understand, and it is just a button click in the structural analysis part of it, where we are saying fluid has to be taken from this particular heading and directly take those pressures and forces and do the structural analysis. So it is, you can do it. The other part of it could be in thermal, wherein we are interested in transferring the coefficient of convection H values, and again those can be transmitted. I is open. Please feel free to give your input. Similarly, to the exact results. Question one of them is how close this simulation results are. So as I mentioned before, it is frankly, first of all, it is subjective. It is the complexity, and I understand the fact that we cannot emulate the real world as it is. There is going to be a gap. However, we have control, and we can get best possible results. And that it is also well tested. That is important on certain kind of phenomenon, on certain kind of applications. We get good results. Identity. One is CFD for energy analysis for reduce cost. Answer is yes. Especially if you want to design the air duct in the building such that flow happens throughout the building. Number one. Number two, you want to ensure the right temperature air value and the temperature value as well as the quality of the air that comes inside. Again, you can do it. You can study it, and that should be more than enough. You can understand what is temperature and velocity at which it should be given inside the system. So you are optimizing and reducing on the cost. On the end, you can also ensure that it is efficient in what it is supposed to do, and that works. Okay, what would be the learning path for flow simulation? Frankly, comfortable with a CAD tool. I put it in some simple words. If you start in the morning, by evening you should be comfortable to use the software, especially front end of it. What is understanding the domain, what you want to do, why you want to do, and how you want to do. If you're able with that, if you know exactly what is the output that you are looking at, then it is really easy to implement. Apart from what I mentioned now, it's time and you should be ready to go or meet a production software in your company. There it says that can we do transient analysis, example wall opening and closing. If I understand, we want to understand at different closure levels of wall, what could be the conditions. Either using the what if scenarios, wherein we can change the angle of the and understand the different cases. That is the best way to do it. Yes, there could be a dynamic way, but I think ultimate output that we are looking at is this thing as the pressure drops, the CV values at different closing conditions, and answer would be yes, we can do it. I'm not sure what which scale, because it could be just water, it could be liquid state of water, or it could be another thing. Few things, multiple liquids, yes, multiple gases, yes. Are limited in our capabilities towards mixing these things. It depends on the applications. We have design means by which we can do it. Can we know the decibel values of vibration induced noise? Unfortunately, no. From the software, we cannot get the direct decibel levels. As I mentioned, design means signature distribution, we can find the noise level. So that's the way it is done. However, a specialized software which do only noise prediction, and that different domain in itself. There is a bland fluid structural interaction problems. In SolidWorks, answer is yes. This is what I mentioned a few seconds back. That is one of the strengths. Plus integrated simulation is done in SolidWorks itself, same front end, so it becomes more faster. Good. There are a few concurrent CFD software companies in the market. What makes SolidWorks so unique when compared to other players? Frankly, now this is one of the interesting challenges that I've heard and been hearing. I've heard to the extent that it is almost the similar things what I mentioned now. But when I myself personally ventured into those softwares, I saw that if I take one particular example, that is exporting of forces from flow simulation to simulation, it is just button click in our software. However, it takes around 15 steps in their software. So that kind of integration that they are talking to the end, even though they are saying integration, it is a different product. You might also seen the names; they are entirely different softwares in itself, and even the integration that they are talking has been for almost a year or two. But we tried for almost 15 years, and we have refined it to maximum extent today. So it is, I would say, truly integrated, and it is not just a simple that yes, both softwares can work together or into a single front end. More than that. Is that can we plot temperature versus time graph from transient analysis? Again, yes, we can do it. No doubt, the time dependent analysis as well in the software. There is a HVAC. I think it is more specific on PV values. If at all there are 100 people, it model all the 100 people and how do we view the metabolic rate, etc. Every user, how accurate you want, you have to do it that much. If you want 100 people and their metabolism, unfortunately, yes. You can also have simple junk square boxes representing the metabolism and degeneration, and that can also suffice to what you used to do. To wind analysis, so the input required for that, I would say it is very simple. Then we need to understand more than pressure, the velocity at which the wind is blowing, and of course the pressure is more depending on where it is and conditions or are there some other simulated conditions. So tips the way it is. That's it. It is what you want to know about its wind, and you can simulate the impact of that wind on the structure. There is SolidWorks to use as standard tool for basic multiphysics, example battery thermal management, cooling, etc. Now, frankly, one answer would be yes. It all depends on your exact application. It is present inside SolidWorks, integrated, etc. But the fact is that the front end at a stage could be also seen as just a front end to import a model. It is a front end. However, analysis is done in flow simulation. So if you say it, all CFD software have to import in some way or the other, and done in this way or here. Or I would say I've covered most of the questions. If I missed out on anything, please feel free to drop me an email, or I hope you have filled the polling window option in the polling window that should help you help in connection with us. And of course, anything further we can always discuss in future. My email is present on the screen. Any further flow of questions? I think that's it for today. Thanks a lot for your time. Hope it was useful. Thank you very much.